We'll start the paper. Paper 21. Let me share the screen. Okay. We discussed until 36th one. 15 or 14 more to go, right? Okay. This is the question. 13th one. 37th one. This is the question. A hollow cylinder of radius 10 centimeter rotates about its axis, which is vertical. A small object remains in contact with inner wall if the frequency of rotation is 200 rpm. 200. And a small object remains in equilibrium, right? In contact with the inner wall if the frequency is 200 revolutions per minute, but falls at lower frequencies. Okay. So we need to find what is the coefficient of static friction between the body and the cylinder. That is the question. Now, this is the 37th one. 37th one. You have a cylinder. And the radius of the cylinder is 10 centimeters. That is given. I'll take it as the radius is this one, simple R, that is 10 centimeters given. And there is a small object, right? Now the cylinder is rotating about its vertical axis with an angular velocity omega, and the frequency is given. What is the frequency? Frequency is 200 rpm, right? As I remember, yes, 200 revolution. 100. Wait. Yes, frequency is 200 rpm. 200 rpm. 200 rpm. We can convert it into omega. Now, the cylinder is rotating. With respect to the cylinder, this block remains at rest. Or with respect to the cylinder, this object is at equilibrium. So what are the forces acting on this one? You have weight vertically downward, mg. Weight is trying to move this object downwards. So the frictional force is acting in this direction. This is the frictional force. And since this one is traveling in a circular path, you have the centripetal force, which is given by the normal reaction. And with respect to the cylinder, you can apply centrifugal force. Why? With respect to the lift, the object is at equilibrium. To cancel weight, you have friction. To cancel normal reaction, you have to put another force, a hypothetical force, which is known as a centrifugal force. So centrifugal force is m times centrifugal acceleration. Centrifugal acceleration is also equal to the centripetal acceleration, which is omega square. So now the block is at rest with respect to the cylinder. So when you're considering the equilibrium with respect to the reference frame, you have to put this centrifugal force. Now you can apply the conditions for equilibrium. Upward forces should balance downward. You have friction that should balance the weight. And friction can be written as mu times normal reaction, right? Mu times R. So mu times R is equals to mg. And again, you can write forces to this direction should balance forces to this direction. So in this direction, you have normal reaction. In this direction, you have m omega square R. So we need to find the coefficient of friction, that is mu. So at the place of R, you can place this. So this is equation 1, this is equation 2. You can substitute 2 to 1. So we have mu times R is m omega square R is equal to mg. Now m is gone. Mu is g omega square R. Now you know the value for g. You can find omega. You know radius. You can find mu, right? So first of all, I'll find omega. Omega is 2 pi times f. So that is 2 pi. Frequency is 200 revolutions per minute. To convert into revolutions per second, you need to divide it by 60, right? So that is equals to You can divide it by 220 pi over 3 is omega. Now you can find mu. Mu is G omega square R. G is 10. Omega square is square of this one. That is 400 pi square over 9. Radius is also 10 centimeter. That is 10 into 10 to the power minus 2. And they have given that pi square is equals to 10. So you can cancel. Now you have 9 over 4. This is gone into 10 to the power minus 1, right? 9 over 4 into 10 to the power minus 1 is 2.904. That is 4.5 over 2 into 10 to the power minus 5. That is 2.25 into 10 to the power minus 1. That is 0.225. So the coefficient of friction is 0.225. So the answer is 0.225. Answer is the second one. Second one is the answer. Right. When you consider the equilibrium with respect to the accelerating frame, you have to consider either the pseudo force or the centrifugal force. When it is a linear motion, you have to consider the pseudo force, which is when the reference frame is accelerating in the forward direction, pseudo force will be in the opposite direction, right? So when the object is moving in a circular path, you have to consider the centrifugal force, which is same as the centripetal force but opposite in direction, right? This is 37th. Okay, let's move to the 38th one. Pi square is approximately equals to G. The actual value of pi square is 9.8 something. You can cancel it with G usually, but yeah, they have to mention that. Okay. 38th. Okay, this is the question. Now there you have a voltage applied across a silicon transistor shown are represented with symbol VBE, base emitter, VCB, collector base, VCE. The transistor will operate in the active region if. Okay. There you have a PNP transistor. No, NPN transistor. The voltages are given. This is VCE. This is VCB. This is VBE, base emitter. And there are, we need to find at which condition the transistor operate in the active region. I'll write the answers up. Haripata, I'll remind you the theories. So for a transistor, can you remember when you draw the transfer characteristic? That is IC versus IB graph. IB usually in the microampere range, IB usually in the milliampere range. So when you draw the transfer characteristic, that is like this. This is the saturated current. This region is known as the cutoff region. This region is cutoff. This region is the active region. This region is the saturated region. Saturated region. So basically there are two types of fuses of a transistor. We can either use a transistor as a switch, or we can use it as an amplifier. When you are using it as a switch, you either use it in the cutoff or the saturated regions. When it is in the cutoff region, it acts like a closed switch. When it is in the saturated region, when it is in the cutoff region, it acts like an open switch, switch off. When it is in the saturated region, it acts as a closed switch on. So when you are using the transistor to amplify a signal, we usually use it in the active region. Can you remember? Haribata, in active region, normally, active region, in the active region, IC equals to IB equals to 0. IB equals to 0. IC equals to 0. And VCE is equal to VCC. VC is this one. VCC is the supply voltage. Is equals to VCC in the cutoff region. In the active region, you can write beta. There is a thing called current gain. That is IC over IB. The ratio between collector current and the base current is known as the current gain. This is the current gain. And in the active region, VCE lies in between VCC and 0, right? VCC and 0. In the saturated region, you cannot apply this one. Usually, when you take the ratio between IC and IB, that is usually greater than the current gain beta, right? And in the saturated region, VCE becomes approximately equals to 0. Collector emitter potential difference is approximately 0. Okay. Here this ratio is lesser than beta. When you take the ratio in between IC and IB in the saturated region, that is lesser than beta. Okay. Hari, මේක තමයි වෙන්නේ. තවමනාද කියන්නේ. In the cutoff region, if you are using a silicon transistor, let's say, the VBE is lesser than 0.7 volt. Here, the supply voltage VBE is 0.7 volt. Here also VBE is equals to 0.7 volt, right? Base emitter. Now the question. Now we need to find. See, this is the question. Now we need to find the situation where the transistor operates in the active region. When VB is equals to 0, that means that is lesser than 0.7, right? So at this instant, it is at the cutoff, right? Cutoff region, right? When this one, there you have here also VB is lesser than 0.7. So at this point also it is in the cutoff region. So answer can be this one, answer can be this one, right? So when the transistor is operating in the active region, VB is 0.7, it's okay. VCE, C is the collector emitter. Collector emitter, this can happen, right? Fourth one can happen. Here, VCE cannot be 0. When VCE is 0, Puta, it is in the saturated region. Here, when collector emitter voltage is approximately 0, it is in the saturated region. So if it is in the active region, when you take IC over IB, that is equals to current gain, and VCE should be in between VCC and 0 and VBE 0.7. So answer is, what is the answer? VBE is 0.7 volt, VCE is 0.5 volt. Sorry, 5 volt. So in the first case, the transistor is in the cutoff region. Why? What is the reason? Base emitter 0.7. Collector base is given, right? Collector base is base emitter. In the first case, let's assume in the for the first answer, they have given VBE is 0.7 volt and VCB is 0.7 volt. Okay. In the first answer, VB is 0.7 volt, VCB is 0.7 volt. Hari, I thought more than, let's say the potential at this point is 0. So the potential at this point is how much? VB is 0.7. So the potential at this point is 0.7 volt, 0.7 volt. So VCB is also 0.7 volt. So the potential at this point is 0.7 volt higher. So the potential at this point is how much? 1.4 volt, right? 1.4 volt. So what is the potential difference between collector and emitter? That is this potential difference. How much? The potential difference is 1.4 volt, right? 1.4 volts. Okay. I thought ඒකෙදි මොන region එකේදී CB. This is P, sorry, N, P, N transistor. Base emitter, collector base. No, it can also be in active region, right? But right here, this is forward bias. Base emitter is forward biased, and the potential difference between these two is 1.4. 1.4. Yes, in between. Another Anita answers me, Valo. First again, Puta, VB is 0.7 volt, right? Here VCB is here not VCE. If this is VCE, if VCE is 0.7 volt, we can assume that this is in the cutoff region. Why? What is the reason? If VC is approximately equals to, sorry, I mean saturated region. If VC approximately 0 volt, we can assume that it is in the saturated region. But here VCB is given. Now, in this case also, the transistor can be in the active region. There is a possibility, but at this place, the transistor is in the cutoff region for sure. For the third answer, the transistor is in the cutoff region because base emitter is not forward biased. Here the base emitter is 0.7 volt and VCE is 5 volt. That is directly given. Here the transistor is in the saturated region. I think the most suitable answer is the fourth one. Why? Here Puta, VB is 0.7 and VCB is zero point 0.7. Here VB is 0.7 volt and VCE is 5 volt. When VCE is 5 volt, that means for sure this is much greater than zero, right? So it cannot be in the saturated region. Base emitter is in the forward bias, so it cannot be in the saturated region. So it should be in the active region, right? Active region. So this answer is the most suitable one. You can argue in the opposite way. The first one is also the correct one, but the most suitable answer is the fourth one. Take it as the answer. Fourth one is the answer. For when the transistor is in the active region, VCE should be lesser than VCC and 0. Usually, we keep the VCE, let's say, this is the transistor. Now, this is the transistor. Here you have VCC. Usually, the transistor, let's say VCC is 10 volt. When the transistor is biased to the active region, normally we make that VCE approximately equals to half VCC. Okay, half of VC, half of this one. So when you consider first answer, the VCE is how much? 1.4 volt. That is very less. Usually we bias the transistor so that the VCE voltage is approximately equals to half VCC. That is like a rule of thumb. So here also it is in the active region, but the most suitable answer is answer fourth one. Fourth one is the answer, right? Usually we do not bias the transistor to a low voltage like this. PC is 1.4 volts means somewhat near to zero, right? So the answer is fourth one. Fourth one is the most suitable answer. Okay. Hurry up. Next question. This is the question. Hurry, Putar. Two cylinders of equal volumes, that is the most important point. Two cylinders of equal volumes are immersed in a water beaker as shown in the figure. Okay. The tensions of the light inextensible strings are equal. See, in for the cylinder A, the string is attached from top, and for the cylinder B, the string is attached from bottom. So the tensions are equal, that is given. So you can say that the density of A is greater than the liquid, right? A is trying to sinking. So, and the density of B is lesser than the liquid. That is why it is trying to move upward. The string is holding it at the position. If water is disturbed and allowed to rest, what? If water is disturbed and allowed to rest, after keeping A on B, there you have water, Putal. The liquid is water. A and B, the right position of them is okay. They have equal volumes. That is the most important point. That is the question. 39th one. Now you have a beaker of water. Here you have cylinder A and it is attached to a string and the tension is T. And the weight, let's say mg, and the upthrust is U. And this is A. And there you have another cylinder B. It is attached to a string from the bottom. So the tension and the B is trying to move up, so the tension is acting downward. They have mentioned that the same tension is acting. Weights are different. Weight of this one is, let's say, mass is mb, so the weight is mb. Upthrust is the same, right? Here upthrust you, for this cylinder, the upthrust will be the same. Why? What is the reason? They have equal volumes and immersed in the same liquid. So they have the upthrust is same for both the situations. Now I'll consider A. Okay. When you consider A, Pruta, when you consider A, you can consider the equilibrium. You can write T plus U equals to M. T plus U equals to MAG. And when you consider B, for B you can write Pruta, upward force is U, that is equals to T plus MBG, right? U equals to T plus MBG. Now, you are going to place this A on top of B. You are going to place this A on top of B and you are going to insert it into the liquid. Now we need to find the correct location of the combination. This is water, same density. And these are the two, what do you call, the cylinders. So the total mass is how much now? MA plus MBG. And to balance it, you have upthrust. There is a different upthrust. Let's say U dash. Let's say the submerged volume is V dash. Submerged volume of the cylinder is V dash. Okay. Now uh, how to do this? Now you can add these two. See, this is first one, this is second one. When you add first one with the second one, you have T and T are gone. You have 2U. 2 times upthrust equals to MAG plus MBG. So how to write upthrust? Upthrust is, let's say the volumes are equal. Let's say the volume of each cylinder is V. So the submerged volume is V, density of water is rho, G is equals to MA plus MB times G, right? So when you cancel this G, you have MA plus MB is equals to 2V rho, 2V rho, right, Putala? Now here, the cylinder is, let's assume the cylinder is floating. So when you consider the equilibrium, you can write U dash is equals to MA plus MB times G. So U dash is what? U dash is submerged volume V dash, density of water times G, right? Submerged volume density of water times G is equals to, here Putha, MA plus MB is known. MA plus MB is 2V rho. 2V rho, and there you have G. G gone, rho gone. So if this system is in equilibrium, V dash should be equal to 2V. That means if the submerged volume is 2V, the object can float. So let's move to the answers. See, Buddha, the answer cannot be the first one. Why? What is the reason? To balance weight by upthrust, you need to submerge 2V. So at this place, the weight is greater than upthrust. So the object cannot remain at equilibrium like in this one. This cannot be the answer. This cannot be the answer. Answer is this one. This is the answer. Here, the second is one is the answer. This is the answer. Okay. When this is 2V, the object can remain in equilibrium, right? That is the answer. Right? That is the answer. Write down, Putha. Write down if you need anything. The tension is the same. They have given that. Shall I rest? Next question. 40th one. See, this is the question. The displacement x of a particle as a function of time is given by 40th one. X is equal to a sine bt, a sine bt plus c. The displacement is times t, where a, b, c are constants of motion. Choose the correct statement from the following. The motion repeat itself in time intervals 2 pi over b. That means we need to find the motion repeats in the periodic time, right? Periodic time intervals, right? The motion repeat itself in every periodic time. So we need to first find the periodic time, and the velocity of the particle is maximum when t equals to 0. Let's find the velocity when time equals to 0. And the acceleration is minimum at time equals to 0. Total energy of the particle remains constant. Yeah, we can assume if there is no energy loss, the total energy remains the same. Haribudha, first we will find the periodic time. Now, Buddha, the motion of a particle. Uh, See, Buddha, they haven't mentioned that the motion is simple harmonic, but by looking at this equation, you can say that the object is performing a simple harmonic motion, right? Displacement with time varies sinusoidally. So that is obviously a simple harmonic motion. So for simple harmonic motion, you can write displacement as, how about the a sine omega t plus phi, right? Here a is the amplitude, omega is the angular velocity, phi is the initial phase angle, t is time. So Putha, by comparing these two equations, you can come to a conclusion that the amplitude of the particle is simple length. And omega is how much? Omega is b. And the initial phase is c radians. Okay? Alright. Now Putha, first uh, statement A. I'm going to find the periodic time. How to find the periodic time? That is 2 pi over omega. 2 pi over omega is b. So the periodic time is 2 pi over omega. So A statement is correct. They have mentioned that the motion repeats in 2 pi over b time intervals. That is correct. To do this question, you have to first identify that this, what do you call this? Uh, Motion is a simple harmonic motion. Then only you can come to a conclusion that the periodic time is equals to 2 pi over omega. So by looking at this equation, you can say that the motion is simple harmonic. Now we need to find the velocity when time equals to 0. See, Bhuta, when time equals to 0, you can plug that into this equation. You have x equals to a sine bt 0, right? bt plus c. See, time is 0, so bt term becomes 0 plus c. So you have displacement is a sine c. Okay. Now, Putha, they have given that when time equals to 0, the velocity of the particle is maximum. At which point the velocity of a particle oscillating in a simple harmonic motion is maximum? The velocity is maximum when it is at equilibrium position, right? When a particle is oscillating in a simple harmonic motion, the velocity is maximum at the equilibrium position and zero at the amplitudes. So, Putha, if when time equals to 0, the displacement is 0, you can say that the velocity is maximum. But, Putha, when time equals to 0, the displacement is not 0, right? There is a particular value. This is not equals to 0. So, when time equals to 0, displacement is not equals to 0. Therefore, velocity is not maximum. Velocity is not maximum. There is a particular velocity Okay, which is not the maximum value. So B statement is wrong. In the B statement, they have mentioned, see, in the B statement, the velocity of the particle is maximum when t equals to 0. So we need to find when t equals to 0, the displacement of the particle. If the displacement is also 0, so you can say that the velocity is 0. Sorry, velocity is maximum. So this statement is wrong. B statement is wrong. The acceleration of the particle is minimum when t equals to 0. Can you remember the accelerate velocity is maximum at the equilibrium, minimum at the amplitude. But acceleration is minimum at the equilibrium, okay, and maximum at the amplitudes. Now they are saying that the acceleration is minimum at when t equals to 0. But when t equals to 0, displacement is a sine c. So acceleration is minimum at the equilibrium position. So that is not equals to 0. Therefore, acceleration is not minimum. Acceleration is not minimum. So C statement is also wrong. D statement is correct. In the statement D, they have given that the energy of the particle is constant. Yeah, we can assume that. If there are no any dampings, you can assume that the energy of the particle is constant. So A correct, D correct. What is the answer there? Uh, A and D correct. So answer is first one. For the 40th one, answer is first one. I know. First one is the answer. Hi, write down Puta. Oh no. Okay. Okay, Puta. Next one. 41st. See, this is the question. A knife edge. This one. A knife edge divides a sonometer wire into two parts. The fundamental frequencies of the two parts are F1 and F2. The fundamental frequency of the sonometer wire when the knife edge is removed will be. Alright. For a string, can you remember the frequency of a stretched string? Frequency of the nth harmonic is Fn is equals to n over 2l root T over m, right? T is the tension, m is the mass per length. Now, Buddha, when you consider sonometer, let's assume the tension is constant, mass per unit length here, mass m is mass per unit length, that is a constant. So you can directly write that n over 2l times k, right? K is a constant. That is easy for you. If you consider fundamental frequency, that is 1 over 2l times k. Now there is a sonometer. This is the sonometer wire. And a knife edge is kept to divide the string to two parts. Let's say the length of this one is L1 and the length of this section is L2. And they have given the fundamental frequency of this section. Fundamental frequency of this section is F1 and the fundamental frequency of this section is F2, that is given. So how to write Putha F1? F1 is from this method, fundamental frequency is 1 over 2L1 times K. You can either write T over M. That's up to you. K is easy for me. So when you consider the fundamental frequency of this one, let's say that is fundamental F1 dash, the fundamental frequency of that section. How to write the fundamental frequency of that one is how much? See, the fundamental frequency of that one is F2, sorry, not this is F2. The fundamental frequency of this one is F2. That is equals to 1 over 2 L2 times K. Why K? Same tension, same mass per length. So K is a constant for both the things. Now you are going to remove this knife edge and you need to find the fundamental frequency of that wire. Now you are going to remove this knife edge. Now we only have this wire. So when it is oscillating in the fundamental frequency, what is the length of the string? That is L1 plus L2, right? Total length. So what is the fundamental frequency at this instant? Let's say F dash. Fundamental frequency is 1 over 2 L. Now the length is L1 plus L2 times K, right? From this one, fundamental frequency is 1 over 2L times K. But the length of the string is now L1 plus L2. Now F dash is equals to 1 over 2. Here you have from this one, you can subject L1. L1 is what? K over 2F1. K over 2F1. Plus L2 is from this one, K over 2F2. K over 2F2 times K. You can cancel K. And also you can cancel F may 2. So F dash is when you take the common denominator, you have F1, F2 divided by F1 plus F2, right? When you take the common denominator. So F dash is that. So the answer is, what is the answer, Putal? Answer is this one. Third one is the answer. Okay, third one is the answer. Right up. Okay, next one. Second one. See, brother, this is the question. This is the question. Shown in the graph is The sensitivity of human ear as a function of frequency. See, Buddha, how to read this graph? In this graph, the y-axis is the threshold of hearing. The x-axis is the frequency. Let's say the frequency is 500 hertz. So what is the threshold of hearing? 10 to the power minus 11. If the frequency is 1000, from this graph, you can find the threshold is 10 to the power minus 12. Can you remember in what do you call uh, intensity level, sound intensity levels, you assume that the threshold for the human ear is 10 to the power minus 12. That is, Puta, actually that is for if the frequency is 1000 hertz, then the threshold is 10 to the power minus 12 hertz. The threshold of hearing, the threshold of hearing means the minimum intensity of that frequency that the person require so that he can hear that sound, right? That is the threshold frequency. So actually the case is when the frequency of the sound changes, the threshold will also change. But in our questions, we usually assume that the threshold of hearing is a constant, that is 10 to the power minus 12. But Puta, the real case is when the frequency of the wave changes, the threshold will also change. See, when the frequency is 250 Hz, the threshold of hearing is 10 to the power minus 10. Right. That's how this graph can be read. The curve shows the variation of the threshold of hearing of different frequency. The level of intensity of the sound is 10 to the power minus 6 watt. Now we have intensity of 10 to the power minus 6 watt per square meter. Oh, but the frequency of the sound is 250 hertz. When the frequency of the sound is 250 hertz, the threshold is not 10 to the power minus 12, but what? 10 to the power minus 10. Now you can find the intensity level. Haribuda, can you remember? There is a formula. This is 40-second question. 40-second one. So intensity level is what? 10 log I over I naught. I is the intensity of the sound, I naught is the threshold. Now, here 10 log. Intensity of the sound is 10 to the power minus 6 and the frequency of the sound is 250 hertz. For the 250 hertz sound, the threshold is not 10 to the power minus 12, that is 10 to the power minus 10 from the graph. So when you simplify this, you have 10 log, there are 10 to the power 4, right? When you take 4 out, that is 40 decibel. 40 decibel. 40 decibel. So the beta is, or the intensity level is put up 40 decibel. 40 decibel is the answer. So what is the answer? Share screen. 40 decibel answer is this one. Second one is the answer for the 42nd one. Answer is second one. That is how it is done. So if the frequency of the sound is 500 hertz, the intensity or the threshold is 10 to the power minus 11. When the intensity frequency is 1000 hertz, the threshold is 10 to the power minus 12. Okay, you need to take like that. Okay, right. Okay, next question. See, question 43. In a conducting ring of radius simple R, charge Q is distributed uniformly. P is a point in its axis at a distance A from its center. The electric field intensity, electric field intensity is a vector. So you need to find the electric field intensity at point P and the electric potential at point P. Radius is R, distance is A. This is a good question. 43rd one. Now, there is a conducting ring. This is the conducting ring. And a charge Q is given to this conducting ring, and we can assume that the charge is uniformly distributed. So, Buddha, this is the conducting ring. The radius of the ring is given, that is R, and the distance from here to the point P is axial distance. Along the axis, the distance is simple A, right? That is given. Now, we need to, first I'm going to find the electric field strength at point P. Now, the total charge given to this ring is capital Q. Let's consider the charge is equally distributed. I'll consider a small element charge at this point, delta Q. So how to find the electric field at this point due to this element charge, or due to this point charge? We can, when you consider this ring, the charge is uniformly distributed, okay, throughout the ring. Now I'm going to consider a small point charge delta Q. So due to this delta Q charge, how to find the electric field at this point? Point P, electric field at this point is in this direction, right? Electric field is in this direction. Why? This is positive. When you keep a positive charge, this will repel. So the electric field is in this direction. Now, Buddha, I'll take this angle as theta. This is theta. And this electric field strength is P. You can take component. This is theta. This angle is theta. So this is E cos theta is the component in this direction, and E sin theta is the component in this direction, right? Now I'm going to find this small electric field strength. Let's say delta E. Delta E is the electric field strength due to this small charge. So electric field in this direction is E cos theta. Electric field in this direction is E sin theta. Right, Putha? Now, to find the total electric field strength, you need to consider the entire ring. When you consider the entire ring, what happens? Well, let's consider a point charge at this point. Due to this charge, the electric field strength is in this direction. When you take component, one is E sin theta, other is E cos theta, right? So, Putha, I think you can understand the E sin theta components is when you consider point P, E sin theta components will be E sin theta components will be cancelled off, right? This E sin theta and this E sin theta will be cancelled. This E sin theta and this E sin theta will be cancelled, right? When you observe from this side, point P. When you observe point P, you have E sin theta, E sin theta, E sin theta. Due to each element charge, you have E sin theta every direction. Those things are cancelled. So other components, what are the other components? E cos theta will be added up to give the resultant electric field strength at point P, right? Resultant electric field strength at point P. So how to find the electric field strength at point P? E sine, you don't need to consider E sine theta components. Why? E sine theta components will be around this point P, and each E sine theta component will be cancelled by the opposite point charge. That means the E sine theta components of this charge will be cancelled by this charge. E sine theta component of this charge will be cancelled by this charge, right? So the resultant electric field is in this direction, that is the sum of sigma delta E cos theta components, right? Sum of delta E cos theta component. I think you can understand. So sum of, how to find E puta? Delta E. How to find delta E? Delta E is, can you remember, due to a point charge, when you consider a point charge, let's say this is plus Q, or let's say this is delta Q. How to find the electric field strength at a distance R? This point, P point, you can find that is K delta Q over R square, right? Here K is 1 over 4 pi epsilon, 1 over 4 pi epsilon K delta Q over R square is the electric field strength, right? So, Puta, how to find this electric field strength? That is K charge is delta Q over R square. R is the distance from here to here. How to find this distance? This is R, this is A. You can apply Pythagoras. That is R square plus A square is the distance from here to here. The square of that one is R square plus A square. Square of that one is R square plus A square. Clear? Times cos theta. What is cos theta? When you consider this angle, cos theta is adjacent over hypotenuse. That is A over root R square plus A square. Right? Sum of sigma is the sum. So now you have uh, E equals to sigma K delta Q times A over, when you take the product, that is R square plus A square to the power 3 over 2, right? 1 into half means 1 plus half, that is 3 over 2. Now you need to take the addition. How to take the addition, Puta? Addition of each individual point charge. So the resultant electric field should be in this direction. That is, you need to take the addition. K is a constant, A is a constant, this term is a constant. You can take out. So Ka over R square A square to the power 3 over 2 can be taken out. Now you have delta Q1, delta Q2. You need to take the addition throughout this conducting ring. So you have delta Q1 plus delta Q2 up to delta Qn. When you take the addition, that the sum is the total charge Q. So the electric field strength should be in this direction. K is 1 over 4 pi epsilon naught times A times Q over R square plus A square to the power 3 over 2. That is the electric field strength. That is the electric field strength. Did you understand? Putala තේරුණාද? Roshan, Sam, Sahan. Do you understand? Okay.
Yes, sir.
Hari. So electric field is in this direction. That is how it is done. Now you need to find also the electric potential. The thing with the potential is electric potential is not a vector quantity. It is a scalar quantity. First write down this one. I'll give a few seconds. Then I'm going to find electric potential. Electric field is a vector. So you need to consider the direction. Electric potential is a scalar. Now I'm going to find the electric potential. Now I'll erase this one. When you consider the electric potential, you don't need to consider direction. So how to find the electric potential at this point due to this point charge? Electric potential, let's say delta V. That is how to find that one. K Q over R. The distance from here to here is R square plus A square, the square root, right? So to find the total potential, there are no any directions. So you can just take the sum sigma delta V. So that is Putala sigma delta V is K delta Q R square plus A square, the square root. When you add up the K, this term will be a constant. Q delta Q1, delta Q2, delta Q2, whole thing will be Q. So that is K Q over R square plus A square, the square root. So the potential at this point is K is 1 over 4 pi epsilon naught. Q over R square plus A square is the answer. So potential is this one. Electric field strength is that one. So what is the answer? What is the answer? See, electric field strength is QA 4 pi epsilon naught R square plus A square 3 over 2. Potential is Q 4 pi epsilon naught R square A square to the power half. So this is the answer. Third one is the answer, right? This is the answer. Third one should be the answer for the 43rd one. Write down, Putal. Alright. I'm going to erase this one. Forty-fourth one. See, this is the question. A motor vehicle is moving on a circular path while sounding a horn with constant frequency F0 as given. The motor vehicle is moving around the circular path and its frequency is F0. When the vehicle is completing one cycle, starting from point X. See, Puta, point X is here. So at this point, the velocity is perpendicular to both A and B. So A and B both hurt. At the beginning, the relative velocity is zero. In this direction, the relative velocity is zero. So the apparent frequency and the true frequency are the same, right? So at this point, both A and B will hear the horn or the sound at the same frequency. Every graph shows that one. Now, completing one cycle starting from point X with constant velocity. It is moving with a constant angular velocity. The best representation of the variation of the frequency with time heard by two men at point A and B. Nice. Now, Buddha, this is the question. 44th one. 44. The vehicle is moving in a circular path with a constant angular velocity. Initially, the vehicle is at this point, and there are two observers. This is observer A, and there you have observer B. When time equals to 0, the vehicle starts from here. Velocity is constant. So when time equals to 0, both A and B will hear a frequency of f naught, right? Clear? This is emitting a frequency f naught. The relative velocity in this direction is 0. So, when t equals to 0, frequency heard by A is also f naught, frequency heard by B is also f naught. Clear? After completing, let's say periodic time is capital T over 4 time, the particle is at this point. After T over, when time equals to half, T over to this one, when time equals to 3/4, at this point, when time equals to periodic time, again the object is at this point. Now we need to find the frequency heard by B with time graph. First, I'll draw the frequency heard by A with time. Frequency heard by A with time. For a full circle, let's say at this point, the time is capital T. There you have half T, T over 2. There you have quarter periodic time. And there you have 3/4 periodic time. At the moment, this is the graph is frequency of A with time. Okay. When time equals to 0, the frequency heard by A is f naught. The frequency heard by A is f naught, right? When time equals to 0, frequency heard by A is f naught. So let's say this is the f naught line, f naught level. When time equals to 0, this is f naught putala, frequency of A. Neglect point B for the moment. Now it is traveling in this circle, in this path. Now, frequency of A becomes minimum, frequency heard by A becomes minimum when the source is moving away from him. The frequency heard by A is maximum when the source is moving towards him. So, away and koi wage location ekada? Away from A. Let's say A is somewhere here. This is point A. The source is moving away. The source is moving away at a point like this. At a point like this. Away from A. Right? At this point. So, Buddha, the frequency becomes minimum somewhere in between T over 4 and 0, right? So, frequency become minimum somewhere like here, right? Then the object is moving. Then again, the frequency becomes maximum at this point. Why? What is the reason? The frequency becomes maximum when the source is traveling towards C. That means somewhere in between 3/4 and T, the frequency become maximum. Frequency become maximum. Somewhere there, the frequency become maximum. So the frequency variation, and also at this point, Putame, at this point, when time equals to T over 2, see, when time equals to T over 2, frequency heard by A is f naught, frequency heard by B is also f naught, right? When T here, at this point, the frequencies are FA is C. So when you consider FA, the variation of frequency is like this. Again, after periodic time, it will come to a point like, right? This is a frequency variation of A. But Putha, when you consider frequency variation of B, at which point the source is moving away? Somewhere like this, right? At this point only, the source is moving away from B. At a point like this, the source is moving towards B, somewhere like this. So you can see the frequency for B becomes minimum when the object is at this point. That means the frequency for B becomes minimum. B becomes minimum after the frequency for A becomes minimum, right? That means somewhere there. So the graph of for the this is graph for A, right? Here you have this one. You can exactly draw the graph. Minimum, this one becomes maximum. Uh, becomes maximum. Okay. Here maximum. Here minimum. The frequency for B becomes minimum somewhere there. So if you consider this is FA or FB, FB becomes minimum somewhere like here, like this. However, frequency at this point is F naught. When you consider B, the frequency becomes maximum for A before frequency becomes maximum for B before A, right? Somewhere. So the frequency, this is frequency of A. I'll draw in another pen. Red color is for the frequency of B. When you consider B, the frequency becomes minimum after that for A. So frequency becomes minimum somewhere there, like this. So the frequency at this point is zero. The frequency becomes maximum before A. So frequency becomes maximum somewhere there, and like this. This is for F frequency of B. That is the graph. Let's move to the graphs, Lame. See. So answer cannot be fifth, this one. Answer cannot be this one. See. Answer cannot be this one. Answer cannot be this one. Frequency cannot be constant. So out of this one and this one, what is the answer? Frequency for A becomes minimum before B, right? Before B. A becomes minimum before B. And frequency for B become maximum before A. This one should be the answer. This is the answer. This is the answer. Not this one. Okay. So answer is this one here. The numbers are not indicated correctly. This is the answer. So this one is first one. First, this is the answer is given as first one. This is the answer for that, right? And this is a nice question. All right, I'm going to erase this one. All right, 45th. See, Now you have a galvanometer together with an unknown resistance in series are connected across two identical batteries, each of 1.5 volt. When the batteries are connected in series, the galvanometer records 1 ampere. And the batteries are in parallel, the current is 0.6 amperes. Okay. What is the internal resistance R of the battery? 1.5 volt batteries. Hi. When connect, we need to find the internal resistance. A galvanometer together. We don't know the resistance. Okay. Now, Buddha, this is the question. See, 45th. When two cells are connected in series like this, when they are connected in series, there you have a galvanometer, there is a resistor. Let's say the resistance of the galvanometer is Rg, this is capital R, and the cells are 1.5 volt, internal resistance don't know. 1.5 volt, this is 1 point, EMF is 1.5, internal resistance is R. When they are connected in series like this, the current for the combination is 1 amperes. The current is 1 amperes, right? Current is 1 ampere. You can apply Kirchhoff. When you apply Kirchhoff, sigma E is equals to sigma ER. So E1 plus E2, that is 1.5 plus 1.53 is equals to I times current is 1 ampere. So I is 1. The total resistance is how much? R2R plus resistance of galvanometer plus the resistance of this one, capital R, right? Now, when they are connected in parallel, what happens when they are connected in parallel, Putha? The two cells are connected in parallel like this to the same galvanometer and the resistor, right? Like this, right? This is one E comma R, E comma R. Can you remember, Bhuta, when these two things are connected in parallel, the equivalent of this one is like this. How to find the equivalent? This is G, this is R. Equivalent EMF is E, but the internal resistance become R over 2, half of this one. When two cells, identical cells are connected in series, the EMF is E and the internal resistance becomes half. So E comma R over 2. Now the current is 0.6 amperes. 0.6 amperes. Resistance of the galvanometer is Rg. This is capital R. You need to find the internal resistance of the cell. Okay, that is the question. So how to find the internal resistance of the cell, Putha? You can again apply Kirchhoff. When you apply Kirchhoff, E sigma E is equals to sigma E R. Here E is how much? 1.5. 1.5. Current is 0.6. The resistance is R over 2 plus Rg plus R, right? That is the answer. Now, how to find the answer for this one? Now, Buddha, from this one, you have 2R plus Rg plus R is equals to 3, right? From here, you can divide this by 3. 5, 2, that is 2.5. 2.5, or you can write R over 2 plus Rg plus R is equals to 2.5. Now you can subtract these two equations. So Rg plus R, Rg plus R are gone. So 2R minus R over 2, right? 2R minus R over 2, 3 minus 0.5, 2.5, that is half. When you take the common denominator, that is 3R over 2 is equals to half. So R is equals to how much, Putala? R is equals to 1 over 3 ohms. So the resistance is 1 over 3 ohms. Clear? So the answer is, see, answer is 1 over 3. Third one will be the answer, right? Third one is the answer. Write down, Putala. When two identical cells are connected in parallel, EMF is the same thing, but the internal resistance becomes half. All right, next one. See, 46th one. In an experiment made to determine the prism angle of an acute angle prism, the prism angle is acute angle. Using a spectrometer, the reading obtained for two portions of the telescope is acute. 303 degrees 22 minutes and 63 degrees 20 minutes. The prism angle is. Hari. Can you remember, Puta? For a prism, you can use the spectrometer to find the prism angle. You first level, and after doing everything, you send the light beam sodium vapor lamp. You are going to keep the telescope at this point, and you are going to keep the telescope at this point, and find the readings. Let's say the reading at this point is R1 and the reading at this point is R2. Prism angle is this one. The difference in the readings will give us the 2 times prism angle, right? 2A is equals to R1 minus R2, right? Can you remember? R1 minus the difference in the two readings will give us 2A. 2A means 2 times the prism angle. Now the two readings are like this. 303, 22 minutes. The two reading, let's say R1. R1 is 303 degrees, 22 minutes. 22 minutes. R2 is what? 63 degrees, 20 minutes. 63 degrees, 20 minutes. Now I'm going to take the difference. R1 minus R2. So, Puta, what is the difference? 303 degrees 22 minutes minus 63 degrees 20 minutes. That is trigon 240 degrees 2 minutes, right? 240 degrees 2 minutes. So that is equals to 2A. When you consider A, that becomes 120 something, right? 120 something. So, Puta, they have clearly mentioned that this is a 120 means the prism angle is obtuse. But they have in the question they have clearly mentioned that the prism angle, this is an acute angular prism. So Puta, the prism angle cannot be greater than 90. But the difference in the readings is greater than or the difference in the readings is greater than 180, right? When it is greater than 180, that means the prism angle is greater than 90. So this is 240. So what has happened here? What has gone wrong? Here, Buddha, what has happened is when you are taking the reading, the telescope or the scale has passed through, or the vernier scale has passed through the vernier scale has passed through the zero of the main scale. That's why the readings become greater than 180. See, now think. This is a circular scale. Here you have 0. Let's say this is 10 degrees, 20 degrees, 30 degrees, 40, 50, 60, 70, 80. And so there you have 250 degrees. This is 240 degrees. This is 330 degrees, 320 degrees, so on, right? 0 means 360 degrees. Now let's say, Puta, the vernier scale has moved from here to here. Let's say initially the vernier scale at this point, and finally the vernier scale at this point. And the angle moved is from here to here, this theta, right? And actual angle moved by the telescope vernier scale is this one. So when you take the difference in the two readings, let's say R1 minus R2, that is 340 degrees minus 20. That is how much? 340 minus 20 is how much? 320 degrees. When you take the difference in the two readings, that will give us 320 degrees. But actually, this angle is not 320. 320 is this angle. So when you need to find this angle, how to find this angle? Theta is you need to take 360 minus 320. That is how 40 has come, right? Actually, 10 degree, 10 degree, 10 degree, 10 degree. The vernier scale has moved only 40 degrees. Okay. So if you know the difference in the two readings, how to find the exact angle moved by the vernier scale? You need to subtract this value by 360, or you need to subtract the difference by 360 to find the actual angle. Clear? Here, the same thing has happened here. Here they have clearly mentioned that the prism is acute angle, but when you take the difference, you will get that the prism angle is obtuse. That cannot happen. That means when you are taking the readings, the vernier scale has passed through the circular scale 0. That's why they are the similar thing. You get 240 degrees. Now, Bhuta, actually 2a is equals to 360 minus this one. 240, 2 minutes, right? Here, uh, the angle theta is the angle moved by the vernier scale or telescope. That is 360 minus 242 degrees. Now, 2a is how to find this one? This is 359.60 minutes minus 240 degrees 2 minutes. There you have 58 minutes. When you subtract these things, 19, 119 degrees 58 minutes. That is 2a, but you need to find a. So you can divide this by 2. When you divide this by 2, how to divide this by 2, Putha? You can write this like this. 118 degrees. When you add 60 to this side, you have 60 plus 50, 118. That is 2a. So now you can divide. That is 59 degrees, 59 minutes. 59 degrees, 59 minutes. So the prism angle is, now see, the prism angle is acute. So 59 degrees, 59 minutes. Answer is third one. Third one should be the answer. Okay, third one is the answer. Now, if they didn't mention that the prism is an acute angular prism, you can directly take that 2a equals to 240 degrees 2 minutes, and you can divide it by 2 to find the prism angle. But they have mentioned that the prism angle is acute. So this cannot be the answer. So the thing that has happened is the vernier scale 0 has gone through the circular scale 0, right? Main scale 0. That is the case for the 46. Write down, Putala. Okay, brother. Next one. 47th one. A person wearing spectacles move from room P to room Q. He observes, the person wearing spectacle moves from P to Q. He observed that a thin film of water is deposited on the lenses. Consider the following statement. Consider following that are given as necessary condition for this to happen. Hurry, P to Q. Now, Buddha, now there is a person. The people who are wearing spectacles has observed this phenomenon, I guess. Let's say this is room P. This is room Q. This is the spectacle. This is the spectacle. Let's say the person moves from room P to Q. Room Q. Right? When he travels from P to Q, he observed that a thin film of water is formed on his uh, pair of spectacles. What is the reason for forming a thin film of water? The reason is when he is traveling from here to here, let's say I'll take figures. Let's say the temperature of this room is 20 degrees of Celsius and the temperature of this room is 25 degrees of Celsius. And let's assume the dew point of this room is 24 degrees of Celsius. When he's traveling from this room to this room, his spectacles are at 20 degrees of Celsius. When he travels from here to here, the spectacles are at 20 degrees Celsius, which is lower than the dew point temperature of this room. So what happens is the air particles around or the water particles around this spectacle will reach below the dew point. So these particles will condense. That is the reason, right? So for sure, this to happen, the temperature of room P should be lesser than temperature of room Q. That is the must. Okay. The make all observe that is, let's say you are this is your vehicle, this is your car. You are going on a trip to, let's say, Anuradhapur, and the AC is working. Let's say the temperature inside the car is 20 degrees of Celsius. Now, after reaching Anuradhapur, let's say the environmental temperature is 35 degrees of Celsius and the dew point is 25 degrees Celsius. When you step out of the car, let's say you are wearing spectacles. The spectacles are also at 20 degrees Celsius, which is lesser than the dew point temperature. So what you observe is, you will observe that a thin layer of water will form on your spectacles. You will observe that. Okay. So this to happen, for sure, the temperature of this one should be lesser than this one. Other way around is not correct, right? So that is the must. Let's move to the answers. This is a past paper question actually. See, Buddha, for this to happen, the necessary condition is the temperature of room P should be lesser, right? This one. The temperature of room P should be lesser than Q. That is the necessary condition. There is no any effect from the relative humidity, but we can say if the relative humidity of this room Q room is high, the relative humidity of room Q is higher than relative humidity of room P, there is a higher chance of forming what do you call there is a higher chance of forming uh, what a film of water, a thin film of water, but it is not a necessary condition. There is no any effect from the relative humidity. The only thing is the temperature of that room should be that is a necessary condition, that the temperature should be lesser in room P. So answer B only, B correct. B only. Which of the following conditions should be satisfy the above phenomenon to take place? Definitely, the temperature of P should be plus N only. Answer should be B only. Answer is second one. See? Okay. Alright. That is the answer. 48th one. When two pulses shown in the figure overlap the shape which is not possible. Now, from waves and oscillation, when the two waves are traveling towards each other, you have to apply principle of superposition. Let's say this condition is possible, right? Just before they meet each other. After they complete overlap, this can happen. This cannot happen, right? When half of the wave has come to this side, so what is the rectangular and triangular wave pulses are traveling towards each other. This is in this direction, this is in this direction. So let's say half of that wave has traveled to this direction. So by applying principle of superposition, when you add these two, you will get like this, right? So this is a possible answer. This wave pattern is possible. So when it has fully come to this position, that means when the rectangular wave and triangular wave superimpose, you will get a resultant wave pattern like this, right? This is a possible. So when this is the rectangular wave, when half of the triangular wave has passed, the resultant wave pattern is you have to apply principle of superposition. This part will be add up with the triangular wave part. So like this is a possible answer, right? All these things are possible. So which of the following, which of that one is not possible? What is this third one is not possible, right? How comes? එහෙම වෙන්න බෑනේ. අනිත් ඒවා ටික නම් වෙන්න පුළුවන්. Fourth is possible. Fourth is this one, right? Fifth is possible. So every other thing is possible. The not possible answer is third one. Okay, right. Okay, Putala. Next one. 49th one. See, the electric field lines are distributed around two identical point charges as shown in the figure. The electric field intensity at point A, B, C and D. බලන්න පුතා, the electric field at point A is maximum, right? So answer cannot be third, fourth or fifth. E is maximum. At C, the electric field strength is 0. Why? The electric field due to this charge and this charge will cancel at the middle point. Electric field strength at Z is 0. So answer is E is maximum, C should be minimum. So answer is second. Second one should be the answer. Very easy. Why the electric field strength at point A is maximum? Can you remember, Puta? When there are 2 point charges, let's say you have 2 positive point charges. When you consider 2 positive point charges, the electric field strength with distance graph, this is E. For a positive charge, this is like this. For this positive charge, this is like this. When you apply principle of superposition, these two will superimpose with each other. So the resultant is like this. So at the center, the electric field is zero. Near, when you come closer to this charge, the electric field strength drastically increase, exponentially increase, right? So very close to the charge, the electric field is very large. So electric field at C is maximum. C should be zero. Every other point there is a electric field strength, right? There is a particular electric field strength. So answer is second one is the answer. Easy. 50th one. See, AB is an uninsulated uniform rod. It is not insulated. BC is an insulated uniform rod, but the cross-section area is not uniform, right? When there is a steady heat flow through the rod, the best representation of the variation of the temperature from A to C. For A to C, there should be no any uniform temperature gradient. So this one cannot be the answer. Then this thing, see, this thing cannot be the answer for sure. Why? From here to here, it is not insulated. So there cannot be a constant temperature gradient. So how to do this one? බලන්න පුතා. හරි. කියවෙන එකද 50th one. There is an uninsulated rod, and from here to here, the rod is insulated. From here to here, that is lagged, well lagged. When heat is traveling from here to here, the rate will vary, right? Why? The heat will lost to the surrounding. But when it is traveling from there to there, let's say Q dot, same heat flow rate will maintain. When you consider this section, the temperature gradient, the temp from here to here, delta T or temperature with distance. From here to here, the temperature, there will be no any uniform temperature gradient. The temperature gradient is decreasing like this from here to here. When you consider from here to here, you can apply Fourier, that is Q dot T equals to Ka delta theta over delta L. This is for this section only. So when you consider temperature gradient, that is delta theta over delta L, that is equals to Q dot over K. From here to here, Q dot is same, K is same, but area is increasing. When area is increased, this should be this should decrease, right? When A increases, the temperature gradient will decrease. So the gradient has to decrease from here to here. From here to here also the gradient will decrease. From here to here also the gradient will decrease. The gradient should decrease. From here to here the gradient will decrease. From here to here also the gradient is decreasing. From here to here also the gradient is has to be decreased. When it is like this, the gradient is increasing. This is no. When it is like this, the gradient is constant. When the gradient is decreased, it is like this. So answer is, what is the answer? First one, this one is the answer, right? This is the answer. Here gradient is decreased, but here gradient is increased. Here, no. Answer is, this one is the answer. Okay? This one is the answer. Right, Amputala? එහෙම එක ගන්න. එහෙමයි කරන්න. හරි පුතාලා. paper 21 එක ඉවරයි. මං ඔයාලට I'll send the I think you have completed paper 20 as well. I'll send the handwritten answer sheet for you all. You can go through these things. And if you have any doubt, you can ask me through a WhatsApp message. Okay? Okay, පුතා. එහෙනම් අදට ඇති. එහෙනම් අපි මේ meeting එක end කරමු එහෙනම්. හරිනේ? හරි පුතාලා. එහෙනම් God bless you. We'll meet another day. I'll send paper 20 answers through WhatsApp. God bless you, lamai.